Alright, so we need to solve the following polynomials. So number 1, we have x cubed plus 3x squared is equal to 24x plus 72. So we need to get everything to one side of the equal sign and get it equal to 0. So I'm going to subtract 24x and 72 from both sides. And that will give me x cubed plus 3x squared minus 24x minus 72 is equal to 0. Now this polynomial has 4 terms, which means it's a perfect candidate for factoring by grouping. So I'm going to group my first 2 and last 2 terms together and put a plus sign in between. Then we factor out the greatest common factor from each group. So the first group is going to be x squared. That will leave us with x plus 3. Plus, and then from the second group, you can actually factor out a negative 24, which will leave you with x plus 3. So one of our factors is going to be x plus 3. The second one is x squared minus 24. Now, make sure that this is factored completely. We cannot factor x squared minus 24 any more than that. So now we set each factor equal to 0 and solve for x. So x plus 3 equals 0, subtract 3 from both sides, you will get x is equal to negative 3. That's your first solution. For this second one, add 24 to both sides, and then we need to take the square root, okay, to get rid of that x squared. Anytime you take a square root, remember that you need a plus or minus. So we have plus or minus the square root of 24, but we can actually simplify that. So over here, the square root of 24, factors are 6 and 4, and then that can be broken down into not 2 and 6, 2 and 3, and then 2 and 2. So there's your group, your pairs, and then the 2 and the 3 will stay inside and be multiplied to become 6. So your solution is going to be plus or minus 2 square root of 6. And that's your second solution. For number 2, always look for a greatest common factor first, but in this case we don't have one. So notice the pattern of your exponents. It goes to the 4th, squared, and then nothing. This is a perfect candidate for the a equals x squared, which means that a squared is x to the 4th. So what we're doing is we're taking this quartic and turning it into a quadratic. So we can substitute x to the 4th is now going to be a squared, and then x squared is now going to be a. And now we can factor this. This will need to be Berry method, and this was actually a problem on our first do now. So we need to multiply a times c. 4 times negative 9 will give negative 36. Two numbers that multiply to negative 36 but add to positive 35 is going to be 36 and negative 1. So in your factored form, you need to put your Berry in with both factors, and then we need to factor out a Berry. So I'm going to take it out of the first one, and that will give me a plus 9. And then 4a minus 1. Now that we have it factored, we can substitute back in our x's. So a is x squared, so it's going to be x squared plus 9, and 4x squared minus 1. So now this is factored completely. We need to set each factor equal to 0. So x squared plus 9 is equal to 0, and 4x squared minus 1 is equal to 0. So subtract 9 from both sides, and then take the square root. Okay, so the square root of negative 9, the negative will come out as an I, which, let me rewrite this, and then the square root of 9 is 3, so this will be 3i. And since we took a square root, we need a plus or minus in front. For 4x squared plus 1, we need to add 1 to both sides, and then divide by 4, and then take the square root. So x will equal plus or minus the square root of 1/4, which you can take the square root of 1 by itself and then the square root of 4 by itself. So the square root of 1 is 1. Square root of 4 is 2. So this is plus or minus 1/2.